Hi all. In this video we are going to see about how to configure an access list. Let's get into the concept. This is our lab scenario that we are going to use. There are 3 routers and we are going to configure access list between these routers. And this is a task that has to be done. Okay. I have already configured a interface IP address and OSPF configuration for reachability. Just take a look at this. This is my interfaces and you can just look at. I have configured a OSPF1. The router ID of this is 1.1.1.1 and I have advertised all the networks to the area 0. And also look at over here, I have advertised all the networks and the router ID is 22.22.22.22 and I have created a 2 loopback interfaces for here. And check it over here. The same thing I have done it for here, I have advertised all the networks. Okay, this is what I have completed. Task 1 and 2 is gets completed, and this is for a task to create a standard access list in R1 that denies all traffic with the source 2.2.2 from R2. Okay, I just want to create an access list over here which will permit everything, but denies a traffic from here with a source of 2.2.2. That is a loopback 0 when we try to reach the router R1, which will be the interface that has a source of loopback 1, that is a 2.2.2.2, has to be denied, should not reach the router R1 interfaces. That's what the task that we have to do. Okay. First, I'm going to create this is a standard access list. So, in order to create an access list, and you can check it for 1299 standard access list, and the extended standard access list is 1300 to 1399. I'm going to use the access list number 1 over here, and then we need to deny, that is from the source of 2.2.2.2. Okay, this you can see it clear as you can give a host as host, and if you want to specify a particular IP, that's not a network segment, a single IP, you can just mention as a host or with the IP address and 0.0.0.0, whatever it be. Okay, I can also specify like this 0.0.0.0. If you check that it will only specify this 2.2.2.2. There's no other IP address or anything over here. So that's the reason behind this. And I just want to permit it, or else everything will be denied. If you want to confirm, you can just check it over here. If I try to ping, but I haven't applied on the interface. You can apply it on every interface, that's not an issue. But I'm going to, since I'm going to create a different access list, so I'm going to advertise, or I'm going to apply the access list onto the particular interface. That is for R2, it's passed it in 0/0. Okay. And if I try this, it's showing as unreachable. So the source as loopback 0 is also unreachable, and I can't even reach 192.168.12.1 it's also unreachable. Everything is unreachable. And you can also check as the neighborship will also be down after a couple of minutes. So in order to avoid that, yeah, the neighborship is down. That is, you can you have lost your neighborship over here, and it moves out to init state. So this might be the issue. If we haven't give a permit init statement, it will block everything. So in order to avoid that, just want to give a permit init statement. That's it. Yeah. Now it's changed from sorry to full. It is done. If you try to print this will print. This also will print. Now nothing is denied. But if you try to print with a loopback as 0, you will see it as unreachable U. It's unreachable. It's not reaching the particular destination. This is what we have to do. Our task is completed for the first access list. But if you want to confirm, it's been blocking all the loopback interface. I have created another loopback interface. If you ping with this interface, loopback 1, it's trying to reach this. Loopback 0 is only blocked. Since the loopback 0 is 2.2.2.2, you can also check it over here as gaining this, so that only it gets blocked. That's the reason behind this. And we move on to the next task. That is, we need to create an extended access list in R2 that is all the traffic only from 3.3.3.3 to reach 2.2.2.2 on R2. So what you have to do is you need to configure access list in R2 that has to block the loopback 0 interface of R3 to reach only this, that is 2.2.2.2. That's what we are going to do. Okay. Just check if any other access list is being configured. We already have configured the access list. Need to remove that. Okay. Okay. We are going to create an extended access list. Extended access list ranges from 100 to 199. That's what normally we use. Then we just want to any a particular that is from 3.3.3.3. Okay. You can use as here. If you check it, there are many options. If you are trying to block IP, that is a particular, in order to reach, you can use the IP. But if you are using some sort of telnetting or web or some other that belongs to a port number, it's better to use a TCP because IP doesn't support that. And if you want to block only the ping, everything should has to be allowed, you can use ICMP. There are many options. If you look deep into it, you can just check out it. If you want, you can write in labs. Then now I'm going to use this IP because just want to block it everything. Access it 100. Then any IP, we are going to block the traffic from 3.3.3.3. So 3.3.3.3 and towards 2.2.2.2. That's it. We want to permit everything. Then we just want to apply to the interface. Towards R3, we are just looking into it. So it's partition 0/1. I'm calling it as inbound since it is from outside traffic, which has to enter. I'm just blocking it. So if I try to reach this IP, it should be reachable. But if I try to reach this with the loopback 0, it should not be reachable. I create another loopback, it should be reachable. You can also try with 192.168.23.1. So loopback 0, it should be reachable. But in the before access list, which I have created over here, it should not be reachable. That's the difference between standard and extended access list. Extended access list can do many things, but a standard access list can choose only the source IP from which it can be blocked. That's it about extended access list. Create a named access list in R3 that allows only 33.33.33.33 gets connected to this from HTTP server. Okay. We want to create it in R3. So I'm going to create a named access list. That's the difference between standard and extended and named access list. For a normal access list, we just create the access list and put the number. But while in case of named access list, you just want to create IP access list. Just make a note of it. You have to type as IP access list, and you can just give it belongs to the extended or standard. I'm going to use the extended, and I'm just typing name as HTTP. So this is what how to initialization process, that is for creating an extended named access list. And that's one more advantage of using a named access list is that we can edit or we can insert any new statements between the access list. While in case of standard or extended access list, we need to, if you want to insert before statement or in between statements, we need to remove the entire access list and re-again configure or adding to all the statements stuffs entire thing. This is one main advantage of using a named access list. Okay. Then I'm going to permit only so from 1.1.1. That's what I'm going to do. Now permit TCP. Then we just want to allow confirm is there any other access list. Okay, already there's some access list, so I'm going to remove that. The access list. Then it's extended HTTP. So then it's permit. I'm going to permit from the source TCP, which should be allowed from the 1.1.1. segment. Again, keep it as source, and the destination would be 33.33.33.33. And here is the stuff that we need to know about it. There are many lot of things, that is a port number, lesser than port numbers, higher than port number, show the things. But now what we are going to use is it's a equal, that is a match only to a certain port numbers. So equal to, then if you give a question mark, you can just get into it. I'm going to use about a HTTP, that's a port number 80. You can use www or HTTP or 80, so for 80. Now you can check show IP access list. Don't need can. Okay, this is what we are going to do. And then it's permitting. I'm going to deny everything. Deny IP any. Can just look into the access list. Okay, and now I'm going to configure it on the interface. Show IP access list. CDP neighbors. It should be connected to the R1, which is pass within 0/0 and IP access group. It's HTTP inbound. Okay. If I compare this, there is one more issue is that because we are just permitting only from the source of 1.1.1 towards this. So there is an issue in the neighborship to gets down. There's a OSPF neighborship gets down. You can check into it. You can just check here that the timer is get expiring. That is 14 seconds only is there. 6. After a couple of seconds, the timer gets expired and you won't see this neighbor. Yeah, let's get down. So in order to avoid this, while in case of real time, the server will be a single IP. It's not belong to a different access list. There will be no communication between the OSPF neighbors. There will be no data transmission of routing protocols to the host. So that's a major advantage. If you configure this, it will be entire thing gets worked. There's no issue in terms of connecting to the host. That is a HTTP servers or whatever it be, because there will be no routing protocols between it. But in case of lab like this, you can overcome this by using another ACL. Okay, what I'm going to do is I'm just creating another one statement before the 20th statement. Okay, I'm going to create a rule 10 which permits. What is going to permit is, since I have configured an entire topology in the OSPF, I'm going to permit OSPF any in. So that's it. This is the statement that I'm going to add, and once it is done, everything is just okay. Now it's there's no issue in terms of OSPF neighborship because it permits everything in terms of OSPF. So neighborship will not get down. So everything seems to be fine. I just want to check one more thing. Just check it whether the IP HTTP server is enabled or not. If it is not enabled, just type the same command, that is IP HTTP server. That's it. If it is not enabled, you just enable it, or else the HTTP port will not get connected. So that's it about configuration. We can just verify our configuration. Okay. We are going to R1, and now I'm going to try to connect it to the concerned port 33.33.33.33, the port number 80. It is showing as I am unable to reach a particular destination. Okay. Can also check it. Is there any matches over here? You can just check the it has a 27 matches. And now I just check with the source interface with the loopback 0. You can check it here as it's open. Okay. Now we can just check it whether it is matched or not. Yeah, it's connecting. Now it's connecting from the particular source interface. With this interface, we can able to reach this server. If you try to connect once again, you can check some more matches over here. It's 33 matches. That's it about ACL. If you have any queries or doubts, just comment it. That's it. Thanks for watching. Until next time.